Okay, good evening, good morning, good, good afternoon, depending on where you're watching from. Yeah, uh, tonight or this morning, I will be looking at this particular problem. The problem says determine the particular solution of the equation d square y over dx square minus 3dy over dx equals to 9, comma, given the boundary conditions that when x equals to 0, y equals to 0, and dy over dx is equals to 0. It's a very simple question. I'm going to break it down for you to know it and understand it better. Is that clear? But if there's any question, don't hesitate to ask. But try and do me a favor. Make sure you like, share, comment. Thank you. I love you. Okay, yeah, this morning, this is the equation. The equation is d square y all over the x square minus 3dy all over the x. This is equals to 0. You don't need a prophet to tell you. You know that this is a second order differential equation, and order 1 degree 1 and non-homogeneous. Why? Because it is equals to a constant. There's a constant. The constant there is 9, true or false. So what we need to do here is, it means we are going to find 3 things before we can get to obtain the value of particular solution, because he said determine the particular solution. So how are we going to find the particular solution in this second order differential equation? This is what we are going to do. It's simple as ABC. Amen. One, we are going to consider CF. CF means complementary functions. This implies that complementary functions. Amen. Yeah. Complementary functions, and we are going to consider PI. PI implies particular integral. Amen. Then we now go ahead to consider general solution. Consider general solution. General solution is of this one. This is equals to u plus v. It means from complementary function, complementary function is our u equals to a exponential m1 x plus b exponential m2x. This is our complementary function. Then while our particular integral is v equals to kx. So on the long run, we are going to consider the value of k. Then anything we have to use it to multiply x. So v equals to mx. Anything we get. Is that clear? Then we now move to consider the particular solution using the boundary condition. x equals to 0, y equals to 0, dy over dx equals to 0. But if truly they want to confuse you, sometimes they might just say x equals to y equals to dy all over the x is equals to 0. So this means that this implies that x is 0, y is 0, dy over the x is what? 0. So you should take note. Is that clear? So this is how we are going to solve this problem. Amen. Do you have any question? If you have any question, ask. Oh, good evening, sir. Who is my favorite mathematician? I should try matrix also. Maybe next time I will do so. Okay. Where are you watching from? Which country are you watching from? Okurut, Uma. Okay. So, can we proceed? Let's proceed. So, this is how you are going to solve non-homogeneous second order differential equations. It means you first consider the complementary function, which is u equals to this. Then go ahead to consider the particular integral v equals to this. Then you consider the general solution u plus v. Then you use the boundary conditions to find your particular solution. That is what we are going to do. I'm going to break it down for you to understand. So in case you don't understand, please try and ask questions. Drop it in the comment section. Is that clear? Okay, let's go. Let's go. So I'm going to use the operator approach to solve this. So this implies that using the operators, amen. Okay, the operator. It means our our D represents d all over the x, and d squared represents d squared all over the x squared. Amen. Do you agree with me? Okay. So if you agree with me, this implies that here we are going to substitute in d squared here, then we'll substitute in d here. But mind you, it has nothing to do with the y. Is that clear? So this is how we are going to put it in this form. It means d squared y minus 3dy equals to 9. Do you agree with me? Two of us. Any question? So if you agree with me, it means y is common. We can factor it out. Our d squared minus 3 d open brackets close bracket equals to 9. True or false? It's true, right? So let's try and obtain our auxiliary equation. It means for us to obtain our auxiliary equation, this is here is m squared minus 3m all in bracket y close bracket y equals to 9. So if this y not equals to 0, it means our auxiliary equation m squared minus 3m will be equals to 0, and this is the auxiliary equation. Okay, yeah, this is the auxiliary equation. Why is it called an auxiliary equation? Because we are able to find it from a differential equation. It was extracted from a differential equation, so it is known as what? Auxiliary equation. Yeah, it is a quadratic equation, but as long as differential equation is concerned, we refer it as what? Auxiliary equation, as a mathematician. Is that clear? So take note. So it is from the auxiliary equation that we can find our roots, talking about m1, m2. Like your quadratic equation, you know that you are going to find, if we have ax squared plus bx plus c equals to 0, so the roots are m1 and m2, x1 and x2, two of us. So likewise, this is what we are going to consider m1 and m2. Amen. Any question? Do you have any question? No question? Okay, let's proceed. So if there is no question, let's proceed. All these ones we are doing, we are trying to consider the complementary function. That is what we want to look at. Amen. Okay. So far so good. So if you agree with me, it means here, if you can see what I am saying, we don't need formula methods. You know that we have m squared, we have 3m here, so we factor 1m out. So here is m, open bracket, m minus 3 equals to what? 0, right? Okay. Minus 3 equals to 0. So if you can see what I am saying, you don't need a prophet to tell you. Yeah. So it means we can now write that our m1 is equals to 0 and m2 equals to plus 3. Two of us. If this equals to 0, then m minus m3 equals to 0. Which is m2 is equals to what? 3, right? Okay. So it means our complementary function will now be u is equals to a exponential m1x plus b exponential m2x. Here we have our m1 as well 0 and m2 as 3. So it means here our complementary function will now be a exponential m1 is 0, so x times 0 plus b exponential m2 is 3, so 3 times x. So you can now see that here our complementary function will now be a exponential x times 0. It will give us 0 plus b exponential 3x. So complementary function we are going to have a constant. How? Because this exponential is 1, because anything raised equal 0 is what? 1. So if you use 1 to multiply a, the complementary function will now be a plus b exponential 3x. Do you agree with me? Do you understand? If you don't understand, please drop a question in the comment section. I'll be glad to answer you. Any question? No question. Okay. So if there's no question, it means we can proceed, right? We can proceed, right? Okay. Yeah. If there is no question, let's proceed. So it means we're able to find our complementary function. So let us consider particular integral. Is that clear? Let us consider particular integral pi. So now since the complementary function, we have a constant here. Is that clear? So what we need to do here is we are going to let v to be equals to kx. Then we recall this here. That is open bracket d squared minus 3d. We substitute, instead of y, we substitute in v. So here will now be open bracket d squared minus 3d, close bracket. Instead of this y, we'll replace it with what? This v. Then equate it to what? 9. That is how to consider the particular integral. So can you see now? So now here we are going to, we said let v equals to kx. So instead of v, we are going to substitute in kx. Yeah. So here will now be excuse me, open bracket d squared minus 3d, close bracket kx equals to 9. Amen. Do you have any question up to this point? Any question? No question. It means we can proceed, right? Okay. Ask your question, please. No question. It's okay. So let's proceed. So at this point, what we need to do here, we have to let us open this bracket. Let us open this bracket. So if you agree with me, we open this bracket. Excuse me. Let us open this bracket here. So if we use this to multiply, we are going to have d squared dkx minus 3 dkx equals to 9. Equals to 9. Can you see now? So now this d operator means you have to differentiate what is here. So if you see d kx means differentiate this function once, but when you discover that you have d open bracket, d square, open bracket, kx. It means you differentiate this function, what is inside there, how many times? Twice. So just like this is how it is, y is equals to kx. So you are differentiating this with respect to x, how many times? Twice. So if you differentiate the y all over the x, here we're going to give us k. Then if you differentiate d square, you differentiate this function again all over the x square, this will going to give us what? 0, true or false. So as you can see now, you don't need a prophet to tell you. It means this, with this explanation, this implies that d kx is equals to what? K, true or false? Yeah. Then our d square kx is equals to what? Is equals to what? 0. True or false? Okay. So it means here, look here, look here. It means here, already I have explained it. It means here is 0, true or false. So we write 0 minus, we have 3 dkx. But when we differentiate this kx, we obtain k. So use the k to multiply the constant 3 here, equate it to what? 9. So here will be 3k equals to 9. Do you agree with me? Exactly. So, yeah, some of you might ask, you don't understand how this is equals to k, this is equals to k squared. I said, let me take it all over again. I said here we have a function here. So just like you know your implicit function, that when you are given x squared plus y squared equals to 0, this is what you do. D all over the x, open bracket, x squared plus d all over the x, open bracket, y squared, true or false, equals to what? 0. And from the beginning, I explained all this, true or false. Look at it here. D represents d all over the x. Then d square represents d square all over the x square. So you don't need a prophet to tell you, as we have d all over the x, then open bracket kx, it means differentiate what is here, and already this is the same thing as d, true or false? True or false? So when you differentiate what is here, you are going to have k. Then this other one, d square all over what? The x square. Then you are differentiating k, which is equals to d square, which is equals to, with respect to x. So when you differentiate this, this is what you are supposed to have. Do you agree with me? Any question? No question, right? Okay. Oh, there's no question. Shegun, you're welcome. Where are you watching from? So we can proceed, right? There's no question. Let's proceed. Okay. So far, so good. Let's proceed. Let us proceed. So here, 0 minus 3k is minus what? Minus 3k equals to 9. So we are going to obtain the value of k. If we divide through by minus 1, it means our k is equals to 9 minus 9 all over 3, where k is equals to minus 3. So now we now come back to the particular integral. Let v equals to this It means our particular integral, therefore, particular integral will now be v equals to kx, then where k is what? Minus 3. So v will now be equals to, instead of k, we write minus 3. We use minus 3 to multiply x. So here will be minus 3x. Do you see now? Are you following? So now, we can now obtain our general solution. True or false? It's true. Because initially, I said general solution is equals to u plus what? V. True or false? It's true. So we are able to obtain our u as this, and we are able to obtain our v as this. So what we need to write is our general solution will now be y equals to a plus b exponential 3x. Then our v is equals to minus what? 3x. Can you see now? So this is our general solution. General solution. This is our general solution. But the question says find the particular solution. So now we can easily obtain the particular solution. Why? Because we were able to obtain the general solution. Is from the general solution, by the help of the boundary condition, we can obtain our particular solution. Otherwise, we cannot obtain our particular solution. The particular solution is you are coming back to substitute in for A and B. So any answer you got from A and B, then you substitute it back. That is your particular solution. Do you agree with me? Please don't forget to like, comment, and share. I'll be very grateful. Is that clear? So that is that. Any question before we move to consider the particular solution? Do you have any question? No question. Okay. So at this point, what we need to do, we have to recall the boundary condition. We now write, given the boundary conditions, that is x is equals to 0, y is equals to 0, and the y all over the x is equals to what? 0, right? So what we need to do here is x is 0 when y equals to 0. So using the general solution, if you see y, you write 0. So here will be 0. You agree with me? 0 equals to a plus b exponential 3. Your x is what? 0. Times 0, then minus 3 times 0. Amen? So you can now see that here 3 times 0 is 0, and exponential 0 is 1. 3 times 0 is 0. So you can now see that you are going to have a plus b equals to 0. Let us name this one equation 1. Do you agree with me? Then, at this point, since we have been given dual over the x equals to 0, so it means from the general solution, we have to differentiate the general solution with respect to x. That is where we can obtain our dual over the x. Then we substitute in, then substitute x equals to, so that we can be able to obtain our A and B. Is that clear? That is how to find particular solution. Amen? Okay, yeah. So if we differentiate this with respect to x, you don't need the prophet to tell you. It means our dy all over the x is equals to, here is 0 because it's a constant. Then here we are going to have 3b exponential 3x minus, if you differentiate 3x, we are going to have 3, right? Then we now recall that x is equals to 0, then the y all over the x is equals to 0. Please, can I clean this up? Amen? Okay, let me clean this up, right? Okay, so if you can see what I am saying, we are almost done. You don't need a prophet to tell you. We are almost done. We are almost. So, if you can see what I am saying, amen? If you can see what I am saying, it means what we need to do, we have to substitute in instead of the y over the x. Substitute in 0. So here will be 0 equals to 3b exponential, our x is 0, right? 3 times 0 minus 3. Amen? Okay, because we are applying the boundary conditions here. So if you can see what I am saying, it means this is the same thing as 3b equals to 3. Then to obtain our b is b will now be equals to 3 all over 3 to give us what? 1. 3 of us is 2, right? Okay. Then how can we obtain our a? From equation 1, we can obtain our a from equation 1, right? So from equation 1, by the time we substitute in for b, it means our a plus b is 1 equals to 0. It means our a is equals to minus 1. Can you see now? So now, let us come back to what? Our general solution. Which is what? Y equals to a plus b exponential 3x minus 3x. 3 of us. Okay? So our y is equals to a is minus what? Minus 1. Look at it. Then plus b is what? 1 plus 1. So 1 times exponential 3x is the same thing as exponential 3x minus 3. So can you see now, this is our particular solution. So the final answer will now be our particular solution is equals to exponential 3x minus 3x minus what? 1. This is what they want us to determine, and we are able to determine this. So this is how you are going to solve the differential non-homogeneous second order differential equation, how to obtain a particular solution. Do you have any question? Please ask. Do you have any question? No question? In absence of any question, we are going to call it a day. Thank you for your time. Please make sure you like, share, and comment. I'll be very grateful. Love you guys. Have a wonderful night. Bye.